Bali and I'm on the research team.
Hi, I'm Al Young and I'm part of the hardware and research team.
Hi, I'm Eugene Yang and I'm on the hardware and software team.
Hi, I'm Say and I'm part of the software development team.
Hi, I'm Sasha Stein and I'm on the software development team.
For our first NeurotechX BCI competition, we planned on building a simple setup using the Muse headset. We wanted to detect and discriminate alpha wave activity from other brainwave activity, and then use the presence of those alpha waves to turn an LED light on and off.
In this project, we are attempting to send EEG data to a server via the Firebase real-time database using the Muse EEG headset. So first, the Muse headset reads raw EEG data from the user. This information is then stored and sent via Bluetooth to the TestLib Muse Android app. Now, the Muse Android app software is edited through the Android Studio App Development IDE. And in this development environment, we communicate with the Firebase real-time database, which contains the state of the LED. So from Android Studio, we move to the Firebase real-time database. Now, after the app processes all of this data, we update the state of the LED, depending on whether an alpha level relative threshold is met. Finally, the Wi-Fi module reads the state of the LED from the Firebase real-time database and tells the microcontroller to turn the LED on or off.
For the alpha wave processing, we take the average of the 4 recorded relative alpha values, which is the proportion of alpha waves in the EEG signal. We take this average and compare it to the predetermined alpha threshold. If the average is larger than the threshold, we update the LED status to on, otherwise we update the status to off.
So one problem arose when attempting to use Python as a primary language to edit the EEG data. So originally, installing the bluepy.btle, which is a Bluetooth low energy platform, produced many further complications. Many classes such as BluePy and BluePy Helper needed to be implemented and compiled, along with their own dependencies such as glib, endian, etc. So after all of these missing libraries were finally installed and compiled, they needed to be linked to the core source file, and that produced further errors. Eventually they were linked using CPP flags, but then after that another error arose with attempting to implement the library byteswap.h. So after searching constantly through Stack Overflow and through Google, it was eventually shown that byteswap.h was not an available library for Mac OS. So as a result, Python could not be used to edit EEG data via Bluetooth.
While using the OpenBCI headset, we encountered several connection problems that resulted from things such as deprecated board files and outdated libraries. The first of these issues was figuring out how to program the game on board via the assembly radio module. As these board files were at the end of life, we could not download them, and as a result led to setbacks in programming the Ganglion board. Other issues arise from outdated libraries, in particular from the transition between processing 2.0 to processing 3.0. Several libraries were incompatible with processing 3.0 and processing 2.0. One of these libraries, the Guoptics library, was found to not be updated to be compatible with processing 3.0, and therefore forced us to reallocate to processing 2.0. However, while we were programming in processing 2.0, we found that other libraries were also incompatible, for example, the graphics library. As a result, we ended up using Muse as an alternative headset and decided to program using the Android Studio.
When we were working with the Muse headset, the biggest problem we faced was connecting the TestLib Muse Android mobile app to the Firebase real-time database. After many app crashes, we resolved the errors by experimenting with the Firebase API and developing an understanding of app development in Android Studio. Originally, we were planning to use an Arduino and connect it to the Wi-Fi module, but there were some issues associated with that design. The Wi-Fi module is powered by 3.3 volts, while the Arduino supplies 5 volts. Which meant that we needed a 5 volt to 3.3 volt logic level converter and a mess of wires if we didn't want to fry the module. Luckily, we managed to find a microcontroller with an attached Wi-Fi module, which greatly simplified the circuit.
Once Eugene put on the headset, we had several cameras tracking his activity, the status of the LED light, and the collection of brainwave data on the app. It took him a few seconds to get relaxed, but soon his relative alpha wave activity passed the threshold, and ta-da! The light turned on. Once Eugene realized, he quickly became excited, turning the light off.
So we believe that for our future plans, we can cater this kind of service towards people who lack motor functions in order to control their devices. And so based on the brain behavioral activities that can be detected from their brains, we can use that to control the home appliances, and so they can have an easier time living their lives. And we could also use this for energy savings because, for example, when you're sleeping, you're not really using the lights and you have to turn them off. So we can use those to predict what kind of actions we can take with those home appliances. And we hope to advance this technology in terms of the control users can have over their devices, because our alpha waves right now can only use about one device, where we plan to expand this to create a whole entire ecosystem using Philips Hue lights and other types of home appliances, such as our cameras or our TVs. And so we really hope to make this a bigger thing and to integrate Internet of Things with neurotechnology.
All of us traveled up a really steep learning curve, going from having no background in brain-computer interfaces to becoming knowledgeable members of the neurotech community. We're proud to call this project our first step into establishing CruX UCLA as an influential organization in neurotechnology. Thanks for watching!